All right, Misfits and I had fun watching all your Flipgrid videos. It was good to see and hear people, and people were doing a very nice job of explaining things as they were graphing. It seems like it's going well. We just wanted to highlight a couple things that came up in the videos and things that are traditionally sort of tricky as we're doing graphing rational functions. The first has to do with horizontal asymptotes, and most people are doing a very good job of identifying them. And so in this example, we've got a first degree on top. If I multiply out the bottom, I would get second degree. And so we know in that case, higher degree on the bottom, there's going to be a horizontal asymptote at 0. And what sometimes people were saying, they weren't necessarily getting the graphs wrong, but as they were explaining things, they would say something like, oh, I know the graph never crosses a horizontal asymptote, and they would sort of use that to help them graph. That's often the case, but it turns out it's not always the case. And so you just want to keep in mind that graphs can cross horizontal asymptotes. And so here is that graph we were just looking at. And this is sort of tricky, and people were doing a good job of this. We've got these two vertical asymptotes here. We've got the x-intercept, and we have to have this graph in between the vertical asymptotes, and the y-intercept helps us. Sometimes that y-intercept isn't in this in-between section, in which case you have to do a couple other points to sort of help you figure out the shape, and people were doing a good job of that. If you didn't think about it before, it is good to point out that notice this x-intercept that I'm sort of turning on and off here is right on the horizontal asymptote, and that is just fine. That is not a problem at all. Notice right here, as we approach the vertical asymptote, the graph is nowhere near that horizontal asymptote. That's also fine. Horizontal asymptotes are all about end behavior, and so it's just telling me what happens to the graph out on the end, right? It's getting close to 0 out on the right end. It's also getting close to 0 out on the left end. So we definitely saw graphs like this, and it's just good to call out that it sometimes can cross the horizontal asymptote. This next one is a little trickier, probably trickier than anything we'd see on the test, because you really sort of need a graphing calculator or Desmos or calculus to help you analyze this one completely. Notice the situation: first degree on top, second degree on the bottom. So we're again going to have a horizontal asymptote at 0, but this time there's only one vertical asymptote because I've got that factor repeated. And so notice this is sort of weird, and like I said, sort of tricky. The graph crosses the horizontal asymptote, right? We know the horizontal asymptote's at 0 and the graph's crossing it there, and it sort of goes above it, hits this high point, and then curves back down. And again, it would basically be impossible to find this high point without using Desmos, without using your graphing calculator or calculus, which you'll hopefully learn in the next year or two. So notice the horizontal asymptote's still 0, still approaching 0 out on both ends, but the graph does actually cut right through it in the middle. And that's just fine. All right, next thing is the slant asymptote. And again, people were doing a good job of this, but just to go over the highlights, because it's one of the newer things. So we get a slant asymptote when the degree on top is higher than the bottom. And we find it by doing synthetic division. And so x plus 1 on the bottom means put a -1 out front. I multiply and add. And am I doing this all right? And I can basically just ignore the remainder and just look at the quotient. And so I get y equals x plus 7. And so as we go to graph this, it's just graphing a line. So I'd have a y-intercept of 7, slope of 1. And so this slant asymptote is basically like a horizontal asymptote. It's going to help me draw the graph at the end. If I go back to the original equation and factor, I can see my x-intercepts, and of course I know my vertical asymptote is at -1. And so I've got my x-intercepts at -3 and -5. If I can sneak these in here, my scale is sort of off, sorry, but we get the idea. And we get close to those asymptotes. And what sometimes people do, especially if this vertical asymptote was over on the other side, is sometimes people forget about this upper right-hand part of the graph. Remember, you never want to leave a blank spot. The graph's not going to be defined at the vertical asymptote, but it's defined everywhere else. In this case, I do know that there's a y-intercept up at 15, so it's going to be a little harder to miss this one, but sometimes people do miss it. Like I said, if this vertical asymptote was over on the other side, which is where I should have put this one, it would be maybe a little easier to miss that upper right-hand corner. In this case, though, I've got that y-intercept, and it's going to get close to that vertical asymptote and to that slant asymptote. We can see when I look at this one on Desmos, even on Desmos, it can be easy to miss that other part, right? I mean, you sort of look at the screen, it's like, oh, there's the graph. You can even turn on the vertical asymptote at x equals -1. You can make that dashed. And it's sometimes nice to see the slant asymptote y equals x plus 7. And again, make that dashed. And so we can sort of see that. And now when I scroll up here, if I get up high enough, I can see that that other branch is up there. And if I go back here and change this to -1 and turn these things off, get back in the home screen, again, it's even easier to miss this upper branch because it's way up here. And so you basically just always want to remember there's not a blank spot in the graph. There's always graphs everywhere except at the vertical asymptote. Last thing is the hole. First thing is recognizing that there's a hole, and people are doing a pretty good job of this, but sometimes they missed it. When you get that factor on the top and bottom, you're going to get a hole, and the hole has an x-coordinate that corresponds to that factor that we canceled out. It's also easy to get mixed up on the y-coordinate of the hole, especially on one like this, because people say, oh, I know what happens when I plug in -4, you get 0, and it's tempting to put that hole at -4, 0. Just remember, you have to plug -4 into the canceled version of the equation. And when you cancel something like this, it doesn't leave behind a 0, it leaves behind a 1, right? Because x plus 4 divided by x plus 4 is 1, as long as we don't have 0 and 0 there. And so this canceled version is really 1 over x plus 2. When I plug -4 into this, I get -4 plus 2, which is -2. And so that hole is at -4, -1/2. And so when I go and look at this one on Desmos, it doesn't show up on Desmos nicely until you trace. But now I can see right at -4, it's undefined. And when I'm close to -4, I can see I'm really close to that -0.5, which is where that hole is. So nice job once again on your Flipgrid videos. We enjoyed seeing them. Watch out for all these little details. Do lots of practice, and you'll be ready for the test next Tuesday.